So, hello, my name is Dr. Francis Omonefe, an exploration geophysicist with Frantic Consulting. Quick one, I'll be making a video on how to merge two resistivity lines together. And before you can do that, there are conditions of which you should know the condition. The condition is that, first of all, you should ensure that the data are of the same field. Then they are compatible. Make sure that they are both of the same array. You shouldn't use merging slump merger with dipole. It won't work. Then also make sure that they are of the same coordinates. Also make sure that they are of the same transverse. They should be of the same transverse. Not that one should be going in Y direction and the other one should be going in S direction. It won't work. It will work, but your interpretation might be faulty, or your aim and objective might not be achieved. So let's assume that all that criteria are met. So there are different ways to merge a data. You can merge it manually, but I think we have left the manual word because now we no longer take pen and paper to the field to record. You do that especially in 2D. You don't record okay, electrode 1, electrode 2. I don't think we are still doing that anymore. But assuming you are in that line, you can merge it manually by rewriting your electrode position until you write to the last one. Then you just put your resistivity values. And the second way is to merge through code. If you are using Python, you are using MATLAB, you can just write the code and say merge these two things together. I want to make it one, and those softwares can do it for you. Those can do it for you. And another thing is rest 2D inversion can also do that for you if you know how to write the code as well. So I think that's the easiest one. Just allow the 2D inversion to do it for us. So come on, let's go to our software. Let me quickly do this thing with rest 2D inversion. Let's tell the software to merge our two data. Okay, all right, so we are on the desktop. The data set I want to use, let me look for them. They're in my downloads. Let me quickly drop them in a single folder so that I'll know that I'm working with this folder on my desktop. So I'll create a desktop and call it learning. So inside the learning, I'll be dropping my two data sheets I want to merge. So let me open for one. Oh, I'll name this line 2. Let this be line 1. Let this be line 1. We have 333 Newton points properly arranged. We have some negative values, very high negative values, but that's not our business right now. So this I'll save it, Ctrl S. I just press Ctrl S, then I'll close it. Then let me open for 2. Let me call this line 2. We still have 300, and this is our array type. Our array type is 7. So I'll save it also. Let me quickly bring another thing from my desktop and add into our folder, the merge file. So this is how the code looks like. This concatenation of several data files in rest2d on file. You can get this file somewhere inside your rest2d inversion. Yeah, this file is inside the software when you download it and install it. So you can get this file and just edit it. So this is the file you can use to merge two profiles inside the rest2d inversion. So when you do that, you edit it to suit your stuff. So I'll be changing this code. So we have our file1 parameter, where you have your name of data file in rest2d format. So what they want you to put is the location of the file you want to merge. So this is for 1. I'm going to copy file path and replace it here. I'm going to remove this asterisk, apostrophe rather. Then for file 2, I'm going to copy this part. File 2 parameter, Ctrl V, I'm going to remove this asterisk. So we have these 5 parts. The direction, you need to know the direction of your profile. So let's assume our direction is in X direction. What I mean by that is, let me quickly draw something. Let me open my paint. Pick my pencil. So let's assume this is our field. We have this as our field. There, as you all know, this is your Y direction and this is your X direction. This is your X direction. So at this point, we believe that this is Y0 and this is X0. So we are saying that this is the point we pick our first data. This is where we started our profile line from. And profile line run to a point and stop here. Then probably you got tired, you went home because you couldn't finish. Then you came back the next day and say you want to continue. So probably you leave a distance of 5 meters, or you can continue from here immediately. I don't know how your feet setting is. So let's assume we now continue from this point and mash it down to this point. So say, okay, we want to merge this file and this file together. So this is line A and this is line B. So we are trying to merge line A and line B together. So let's assume that this is 0 to 160 meters, because if I'm using, I think it's about 160 meters long. Then we'll now continue again from 100 and let's say we'll now continue at point 200 to what have you, to infinity. So now these values are very important. So this is from 0. So our 1 is now in 0, 0. Then our 2 is now in 0, 200. So let's just put it that way. So I'll close this pen file. And say this is 0, 0, which is for our file 1, and our file 2 is now 200, 0. Because this is your Y direction. This side is your Y direction and this is your X direction. So we're now in 0, 200, and we'll tell the software to tell us to export our file and call it mesh. So this will be the name of our final file. Let me remove the 1 and call it mesh. Okay, so when we are done with this stuff, we're going to click save. I just press Ctrl S to save it. So I'm going to close this and close this. So I'll be launching my student version of this stuff. So this is semi-demo version, which is one everybody have, mostly every student. So let it not look as if I'm using a paid one. That's why your own did not work. So I'm going to measure the software. So I'll go to my file. You see where you say read data file. This time I'm not reading any data file, because except you want to read your file separate, but we don't want to do that. We want to concatenate our data. So I will launch that. I'll navigate to where I kept the data. These are my desktop, learning, and these are mesh file. So we'll have our mesh file in 5 formats, and I'm going to launch it. So it's merging the 2 files together, and this red part is showing a little bit error, but the error doesn't it doesn't mean anything because it's trying to tell us that your file contains resistivity values very, very high or more. We have high resistivity values, so that's just the error. It doesn't mean that your format is incorrect. So number of files read is 2, and the total number of data point is now 660. So we now have 660, meaning both of them are merged together. So you can close this and close this. You can go and examine your file now. So you can go and say, okay, let's open our folder. Oh, I didn't give it a direction. So I think that thing was saved in our desktop. Okay, so it's saved in our download. So I'm going to drag it back to this place. So it's saved somewhere. I didn't define the location where it should save. So this is our merged data now. So we now have our stuff at 660 with our values merged together. So with this, I think we are good. So you can now read this stuff. So let me launch back my Student version and read this data. I'll go back to my desktop, learning, and this is a merge file. So before I read this merge file, let me read file 1 and see the difference. So we have our resistivity values reading from a negative value that is extremely high to 3,700. So we have some high patches here and here. That's for profile 1. So let me quickly read for profile 2. Profile 2. So I'm ready for profile 2. I just carry out a version without doing any setting. So we have our values reading from negative to a very high value, but nothing is showing here. And our length is 160 meters for both. So now let me read for the merged data, the ones that were successfully merged. So I just read it, and let me just carry out the inversion without doing any setting. So it's telling us that there are some extremely high resistivity. If I want to unstring it, I'll just say yes, do what you like. Do what you like. That's none of my business. Okay. So it's asking me if you should do more iterations. So say, okay, let's do that. So this is our merged data running from 0 to about 360 or so. Yeah, and we have resistivity value from negative -28 to 30. We don't need that negative value because probably there could be something hiding inside this blue and we are not seeing it. So you go to display. The tutorial have ended there. I'm just trying to do some extra in case you are still looking, if you are still looking to look for something. So this is my inversion session, and I'll say, okay, now let's display our results in our inversion session. It's asking me your data sets contain 5 integration. Yes, I want to load all the 5. Now instead of loading this linear contour interval, if you do that, okay, let me click this linear contour interval. I'll click on it and I'll get the result I have before. So this is not what I want. I want to filter away the negative values. I don't want that negative value to show in my results. So I will now use the user-defined linear contour interval. Now, this is telling me that my minimum contour value is from negative, whatever. I'll just say no, I need this to start from 0. Then let me leave this the way it is. That's the maximum value. Okay, so as you can see, I have my inversion results starting from exactly 0. So all the negative values have been filtered out. But I would like, no, there are some, and the unresistivity value here is extremely high, type 4. I would like, no, okay, now I want to still trim the 2 because the minerals or what I'm looking for does not have resistivity value this high. So let's reduce the resistivity value. Let's cut away some unnecessary information that I don't need. So I'll go back again and say, okay, let's do this stuff again. Let me display my version again. Let me trim the areas I still don't need. So now I'll start from 0. Now this contour value, that is 24. 4K. Let me leave it at 1K. So at 1K, I'm seeing some information, and now my bar is now ending at 14,000. We're like, hey, okay. So like this, I think I am good, because maybe probably the mineral I'm looking for is around 10K. It has 10K resistivity, or 12K resistivity, or 14K resistivity. I mean 40,000. When I mean K, I mean 1,000. You know what I mean? Aha. Let me end the tutorial here. I just did aproko. I think I was not supposed to reach this point in this your tutorial, but if this video have helped you in one way or the other along while you were watching it, I think it would be nice for you to just subscribe to the channel, comment. Thank you very much. You have helped me along the line. Also, just share it. Share it. Nobody will kill you. Share it to students. I'm here to bridge the gap between the industry and the academic, because I see that many students graduate without knowing one thing in software application, which is actually geophysics. Okay, so thank you very much.